All right, y'all. So I'm going to bring this over here. So this is number one on the quiz. So on the following study, they want me to identify the population, sample population, parameter, and sample statistic. And y'all, let me zoom this in just a little so y'all can see that a little better. So astronomers typically determine the distance to a galaxy, which is a huge collection of billions of stars, by measuring the distances to just a few stars within it and taking the mean, which is the average of these distant measurements. So they want to know what the population is. Well, y'all, the population is going to be all stars in the galaxy. Okay, because that's what we're choosing to do the distances to. So that would be all stars in the galaxy. Now they want me to identify the samples. So y'all, it's impossible for me to measure the distance of every star in the galaxy. So my sample would be all the stars in the galaxy that I selected for my measurement. So that would be D on this one. All right, so the population parameter, that's going to be the mean distance um, between all stars in the galaxy and the Earth. Remember, your population is including everybody that you can choose from. Okay? And the parameter we're measuring, they said up here, was the mean. So we're looking at the mean distance between all stars and the Earth. Now, the sample statistic, that's going to be the mean of the stars that were selected for the measurement. Okay, so your sample was the stars that were selected for measurement. Your sample statistic would be the mean distance between the stars that were selected for measurements and Earth. Okay, y'all, so that was a trick on that one. So let me pull this over to number two. Now, this one, I'm going to show you how to do this problem on Excel. So we did this one in the homework one day where we had the supplier A ball bearings and the supplier B ball bearings, and they wanted us to find the mean and standard deviation from each one of those. And then we had to come down and pick out which one of these was our box plot. So y'all, I'm going to show you how on Excel, I'm going to enter these numbers into Excel and let Excel do all the work for us, okay? So let me pull up Excel for us. And y'all, I labeled this column. I'm going to put the supplier A bearing sizes. And then in the next column, I'm going to put the supplier B sizes. So for supplier A, I had 16.23. I had 16.26, 16.31, 16.35, 16.37, 16.42, and then finally 16.45. All right, so those were all the sizes of supplier A. So we had, looks like seven of them. So let me put in supplier B real quick. So supplier B, I had 16.19, 16.21, 16.24, 16.34, 16.37, 16.41, and finally 16.44. All right, so these for supplier A, the first column, supplier B is the second column. So they want us to find the mean. So remember, the mean is the average. So right here, I'm going to put the mean for A, and then under that, we'll find the standard deviation for A. Okay, so I'll find the mean and standard deviation for A. So y'all, to find the mean, I'm going to come down here and highlight this first column. All right, now I'm going to come up here and go to formulas on the top row up here. It says formulas. And then I'm going to come all the way over here to more functions and then hit the arrow down. So we're doing statistics. So click on statistics. And over here, mean is the average. So I'm going to click average. Whoops, y'all, I didn't highlight something yet. Let me go back. Okay, so by mean A, I'm going to highlight that box. And I'm going to say equals here. Now let me highlight my column and go to more functions, statistical, and get that average. All right, y'all, been a while since I played with this. Here we go. Equals. So grab the mean first and then we'll highlight the column. So average. So right here it says A2 to D2. I need to go from A2 down to A8. So now I highlight my column, put that in. I'm going to hit OK. So the average or the mean was 16.34143. Now the standard deviation, I'm going to highlight the box below it to the right. I'm going to put equals. I'm going to go up to more functions, hit statistics, and go down and get standard deviation. So standard deviation dot P. And y'all let me highlight the column again. So A2 to A8. I'll hit OK. And it tells me I got a standard deviation of 0.07. All right, y'all, let me let people in. All righty. So that was for A. Now I'll do that for B. I'll find the mean of B. And then we'll find the standard deviation of B. So y'all, I'm going to put my equals, go grab the more functions, statistical, and go to average. So I'm using B now, so I'm going to highlight the B column, and that'll put in B2 to B8. We'll hit OK, and that gives me 16.314. And then y'all, the same thing on the standard deviation, equals. Come up here to more functions, go to statistical, and we're going to arrow down and find standard deviation. And then highlight our column that we want to use, and then hit OK. All righty, so we would come back to the paper now. And y'all, let me see. They want us to round these to the nearest hundredth. So that's 2 decimal places. So for A, 16.34. I'll keep that a 4 since it has a 1 after it. The standard deviation would be 0.07 since that 7 had a 4 after it. All right, on B, we would make that 16.31. So I'm going to keep that a 1 since it had a 4 after it. And then on the standard deviation, looks like we'll keep that as 0.09. All right, y'all, so going back to the pad. All right, so we would put in our mean we got from A, standard deviation, mean for B, standard deviation for B. Now, we're going to work on this box plot. So for the box plot, we need our median. That'll be the center. We need our lower quartile and our upper quartile. Now remember, and this will give us the shape of the box. And then from there, we need our whiskers. And remember, the whiskers are the low value and the high value. All right, so let's do A here. Now, the median, I'll show you how to find the median using that data, and then how to find the median of the lower half for the lower quartile. We'll get the median of the upper half for the upper quartile. Okay, y'all, so let's go to Excel. All right, so my low value is going to be the 16.23. My high value is going to be the 16.45. Okay, so we got these in descending in increasing order from small to high. So pick your low value and your high value. Now we want the median of this whole thing. So up here, I'm going to do median A. Then we'll do the lower quartile. And then we'll figure out our upper quartile. Okay. And I guess if you wanted to put your low value here, you could. The low value. And then we can come up here and put our high value. All right, so we said the low value was 16.23. And our high value down here was 16.45. So y'all, I'm just going from over here on my list to find those. So the median, and y'all let me put these into order like they'll show on let me put the median in the middle like on the box plot. And then put that lower quartile above it. All right, so I'm going to get the median first. So the median, I'm going to put equals. I'm going to go to more functions, statistical, and they go down. They're in alphabetical order, and you're going to find median. So now I'm finding the median of the whole set of data. So I'm going to highlight the whole column and then hit enter. So our median is 16.35, and y'all, we can tell because that's the middle value. Remember, the median is the middle. So we didn't have to do that to get the middle since they were already in order. But I just wanted y'all to see how to do that. Now for the lower quartile, I'm going to hit equals. And I'm just going to highlight the upper three data. Whoops, let me go back. Let me go get that median real quick. So more functions, statistical, go down and get median. But y'all, this time I'm doing the lower quartile, so I'm going to pick the three low values and then hit OK. All right, now on the upper quartile, I'm going to hit equals, go to more functions, statistical, median, and then highlight our lower half of data. Oh, y'all, let me clear these real quick. I forgot I got 7 points over there, right? So I was only using 3 of them instead of all of them. I need to go from the lower half and then hit OK. Oh, y'all, one more time. Statistical, median, lower half. All right, I'll get squared away in a second. Trying to see what these little boxes are saying. Oh, it's just telling me I got numbers next to it. Okay, I was thinking it was giving me an error. Okay, because I got another line I'm doing. So that was for A. Now for B, I'll get their low value, lower quartile. What was next? Their median for B, the upper quartile, and then finally our high value. All right, so we're doing this on the B column now. So that low value for that one was 16.19. So y'all, that was what, 16.19? The high value was the 16.44. All right, my median is going to equal, go to more functions, statistical, go to median, and then highlight the whole column and enter. All right, that lower quartile equal, go get median, and it's the lower half of the data, so that'll be the top 3, enter. And then y'all, my upper quartile, one more time, that's going to equal. So you always got to put equals in there when you're using a formula, okay? More functions, statistical, and go to median. All right, so I'm doing the lower half, so that'll be the lower half and okay. All righty, so I got the data we need for our box plot. All right, y'all, so let me write that down. 1623, 1626, 1635, 1642, and then 1645. That would be for A. And then for B, we had 16.19, 16.21, 16.34, 16.41, and then the high value, 16.44. 4. So y'all, I was just throwing that data down real quick and making the whiskers based off our low value, lower quartile, median, upper quartile, high value. So I wrote them numbers down for both of these so that we can choose one of these graphs for each. So y'all, here was our data from A. I'm going to sort of fold this so we can see it here. So for A, our low value was 16.23. Well, y'all, it can't be A, no whiskers. So it's either got to be B or C. They're the only ones that's got the complete box. Cannot be D. So I need to see which one of these looks like that low value is at about 16.23. And y'all, this first one is left of the 16.2, so it cannot be B. So let's look at C. Now, see, that's a little bit past 16.2, so that could be around 16.23. My high value was 16.45, so this side is going past 16.4, so that'd probably be around 45. So y'all, we got to go with C on this one because it's the only one that's got the low value right and the upper value right. Now on B here, our low value was 16.19. So let's see, this one's to the right of 16.2, so it cannot be A. So let's look at D, the only other choice. So since that's 16.2, looks like the low value is left of that, which would be the 16.19. And then the high value was going past 16.4. And that's what we needed with a 16.44. So for that one, we would want to choose D. All right, y'all. So next, let me pull this camera down. They want to know the percentage that met specifications. So let me pull this down up here. They told us they have to be 16.30 plus or minus 0.1 millimeter. And also, so they got to be between 16.30 minus 0.1, which will be 16.2. And then 16.3 plus 0.1 would give us a 16.40. So I just added the tolerance they gave me and subtracted it from the 16.30 to get the range. So if it's in between 16.20 and 16.4, it passes inspection. So I'm going to start with A. So for A, that one's good. That one's good. They're in between. That one's in between. That one's in between. That one's in between. But y'all, the last two are higher than 16.4. So that means I got 1, 2, 3, 4, 5 bearings that were within my range. Now, let me figure out for B real quick, and then we'll figure out the percentages by dividing. All right, so 16.19, not good. 21's good. 24's good. 34's good. 37's good. But y'all, 41 and 44 are too high. So I had two too high, one too low. So that gave me 4 good bearings on that one. So to get my percentage, I'm going to take each of these, divide by the total number, which was 7, and multiply by 100 to get my percent. Okay, so y'all, for A here, we got 5 divided by 7, and then we'll multiply that answer by 100. All right, y'all, so I'm going to share the calculator. All right, so 5 divided by 7 equals 0.71 times 100. And they want me to round it to the nearest whole number. So that would be 71. So I would leave that at 1 since that's a 4 after it. So that'd be 71%. And y'all would do that for B, which would be 4 good bearings divided by 7. That's going to give me a decimal. Multiply that by 100 to get our percent. Rounding it to the nearest whole number, that one would be 57. So it looks like supplier A had more bearings past the inspection than our supplier B. So now they have already got the percent here. So all you're doing is putting 71 here and then the 57 right there. All right, y'all. So let me see what's the next page. All right, y'all. So this one, they're giving us the number of words defined on randomly selected pages from a dictionary are shown below. They want to find the mean, median, and mode of the listed numbers. All right, y'all. So I'm going to go back to, now we could add them all up, divide by ever how many there were for the mean, and then we could line them in order to get the median, and then the mode would be the one that happens the most. Okay. So I'm going to keep y'all on Excel a little bit to get y'all good on it. So I'm going to go to Excel. Whoops, wrong page. All right, y'all, and I'm going to go to a new book. So file, new. All righty, y'all seen a blank Excel now? All right, y'all, 60, 66, 30, 31, 38, 42, 78, 37, 62, and 33. All right, got the data down. So now I'm going to show y'all a trick that I do to these. Um, I like to put mine in order. So y'all, I'm going to highlight my columns over here. And I'm going to go up here where it says sort and filter and click that. And I'm going to sort them from smallest to largest by clicking that. So now it's got all my numbers in order. All right, y'all. So let's see. I want my mean. We want the median. And then the mode. All right, y'all. So I'm going to put equals here. Go up to formulas. Take more functions. Statistical. And we want the average. So click on average. And then highlight this whole column. So it's going from A1 to A10 and hit OK. Now for the median, I'm going to hit equals. Go to more functions, statistical, and I'm going down to median. And then I'm going to highlight that column again. And okay. All right, now the mode, if you'll notice, when you click statistical, I believe this mode, we're going to do the mode single column. So let me go up here and put my equals. Go grab that mode. And then highlight this column. All right, y'all, so let's hit OK. Now, do you see how it's giving me an NA? That's because there is no mode. All of these values are happening just one time each. Remember, the mode is the value that happens the most. But y'all, none of these happen the most. They all happen one time. So for that, we would put our mean was 47.7. The median was 40. And then since I didn't have any repeating values, we would put no mode. All right, y'all. So 47.7 was our mean. 40 was our median, our middle number. And then, like we said, there was no mode because none of these were repeating, okay? Now, y'all, the way they did the median on this, when we had them in order, they took the difference between the two middle numbers and divided by 2. They added them, divided by 2, and that's how they got that 40, okay? All righty, y'all. So let me find what's next for us. All right, so the lowest score on an exam was 64. The median score was 74. And the high score was 95. What was the range? Well, y'all, if you remember, the range equals the high value minus the low value. So they told me the high value was 95. So we take 95. We're going to subtract our low value, which was 64. So we'll subtract that. That'll give us our range. So let's see, 95 minus 64. One of y'all got a calculator? Punch that in to see what you get. So do me a 95 minus 64. All right, Ashley, what did you get? 31. And good job because um this one says the range is 31 because it's the difference between the low score and the high score. Um And then this one's sort of wrong because they're saying the range was 31 because it's the difference between the low score and the median. We didn't even use the median when we figured it out. So your only choice has to be A, where it was the difference between the low and high scores. Okay? All right, y'all, let's see what 5 has. So a set of test scores is normally distributed with a mean of 105 and a standard deviation of 25. They want us to use the 68, 95, 99.7 rule to find the percentage of scores in each of the following categories. So y'all, let's draw. This is going to be the bell curve that had those percents on it. So let me draw this bell curve real quick. And then we'll put our data on it. All right, so they told us the median, the mean was 105. Okay, they said the mean was 105. In our standard deviation, that was 25. So y'all will go out one standard deviation each side. We'll go out two standard deviations each side. And then our third standard deviation. So one standard deviation, so they use this symbol to represent standard deviation. So one standard deviation will be going one each side. So what you do, you take the 105, you're going to subtract 25 to get one standard deviation less. You'll add 25 to get one standard deviation higher. So y'all, when I subtract 25, I got 80 for one standard deviation. When I added 25, I got 130. So using the 68 rule, that means 68% of the scores are between 80 and 130. Now let's do two standard deviations. And we'll go both directions. So two standard deviations off the mean means we'll subtract another 25. So y'all subtracting another 25 from 80, you get 55. When you add 25 to 130, you get 155. So two standard deviations, that means that 95% will be between this 55 and this 155. All right, y'all, then finally, three standard deviations. So this will be three standard deviations. So once again, you're going to subtract 25, and then you're going to add 25. So adding 25 to 155 gives me 180. Subtracting 25 from 55 gives me 30. So that means, let me draw my lines to the ends here. That means that 99.7% of our data will lie between 30 and 180. All right, y'all, so let's see what they want on this. So they want to know the percentage of scores greater than 105. Well, y'all, 105 is my mean on this, and that splits it between 50% each side. So if 105 and greater is going everything to the right, so that means it's got to be 50% greater than 105. All right, y'all, let me find where my... All right, trying to make this where we can see it a little better. All right. Then they want the percentage of scores greater than 130. Well, that's going to be all of this right over here. Okay. So what we got to figure out, we know that between 80 and 155 is 68%. Okay. in between 55 and 155 is 68% of the data. So you got 32% from here to here and from here to this end. Together, that's 32%. But we're looking greater than 130 here. Oh, I was doing the wrong one. 130 was one standard deviation away. Yeah, I was right. 68%. But this should go from here to here. The 32% would be 16% earth side. Okay, so we took out 68, left me 32%, which was 16% earth side. So the number of scores greater than 130 would be that 16%. Then they say the number of scores less than 80. Well, y'all, we got to round these one decimal place, so make that a 0.0 and a 0.0. So less than 80 would be right here. Well, y'all, that's also one standard deviation. So what it is, we're looking at the scores from this section. Well, y'all, if this right side was 16% of the 32, this left side will be 16% of the 32. All righty. Percentage of scores less than 155. Y'all, here's 155. So I'm looking for everything down here. So what we got to figure out is how big is this part? Okay. So up to 155, from 55, that's 95% of your data. In between here, two standard deviations. That's 95%. That's leaving 5% for this little section and 5% for this little section when you add them together. So added together, these two are 5%, because y'all in between here was 95. So take that 5%, divide by 2, in each of these would be 2.5 each. So we would come in here and put 2.5. All right, next they want to know, let's see, the percentage of scores less than 55. So y'all, right here's 55. Whoops, let me see. Oh, y'all, hold on. I see what we happened. I was doing greater than 155 here. We wanted less than 155. So the number I was reading this wrong. The percent less than 155 would be the 100% minus this 2.5 that was greater. So y'all, I'm sorry, that would be 97.5 that were less than that 155. All right, percent less than 55. Well, here's 55. That's where I was needing that 2.5, because less than 55 was this little tail here. And we said a while ago that the tails were 2.5 each. So we would put our 2.5 there. All right, y'all, let's see what's next. Percentage of scores less than 130. So let's find 130 right here. All right, we know this is 68% in between these two spots. So that's leaving us in while ago we figured from one deviation to the ends was 16% each. So we would take this 68, add to that 16, and get 84. All right, percentage of scores greater than 80. So y'all let me find 80. 80 is right here. So that's everything greater than 80. So if you remember, in between the end and 80 was 16%. So once again, greater than 80 would be this 68 added to this 16%, because remember the ends were 16%. So y'all, that's going to be the same thing. 68 and 16 will give you 84. All right, then finally, the percentage of scores between 80 and 130. Y'all, here's 80 and here's 130. Those were one standard deviation apart. And by definition, anything within one standard deviation would give me 68%. So make that a 68.0. So I guess it helps me if I read my questions good. But y'all, that's what I do to those. I just sort of break it down and figure out what each of these sections have, okay? So, like I said, from here to the end was 32% total for both ends. So divided that by 2 and got 16 for both of those. Then from this to the end, since from 2 standard deviation was 95, that left 5% for each of the ends. And if you divide that by 2, you get 2.5 per end. Okay? So I'm just sort of playing with that to sort of answer them questions. All right, y'all. So let me read this one good before I. The scores on a psychology exam are normally distributed with a mean of 66, standard deviation of 5. A failing grade on the exam was anything 2 or more standard deviations below the mean. So for a failing score, you would take your mean of 66 and minus 2 standard deviations. Well, that's 2 times 5, since that's your standard deviation. So y'all, that'd be 66 minus 10, which would be 56. So the cutoff for a failing score would be 56. And then it says approximately blank percent of the students failed. So y'all, this is going back to that bell curve again. Here's your 66. There's 1 standard deviation, 2 standard deviations. So 2 standard deviations put us at 56. So what we're wanting to figure out is this tail here. And remember, each side has that tail, so you got to sort of split it in two. Oh, y'all didn't tell me to bring that up. Okay, so I'm going to tell you how I got 2.5 based on this one right here. So we know 1 standard deviation was 68% of the data. We know that 2 standard deviations here, between here and here, that's 95% of the data falls in between these lines. 68% was 1 standard deviation. So I'm looking past 2 standard deviations, y'all. So if between here and here is 95% of your data, that leaves 5% for the ends. But that's total between both ends. Okay? So what that means is you would split 5 into 2.5 here and 2.5 here. Okay, and we're going because they said 2 standard deviations. Okay, if that's 95% of your data, that leaves 5 for the ends, and you divide that by 2 to get each end. So that means the percent that would be less than 56% would be this 2.5. Hey, y'all, so those are just based on these bell curves you got to draw. You take your mean, and then you add 1 standard deviation, subtract 1 standard deviation. Then you do it for 2 standard deviations each way, and then 3 standard deviations each way. And then you just got to sort of figure out if you're using 2 standard deviations, you got to figure out what's left and divide that by 2 to get each of them ends. All right, y'all, let me see. So, y'all, that's the quiz. So, next, I'm going to sort of show y'all a project that I was working on. So, let me pull this up. Just to give you an idea, okay? So, I'm going to share my screen. All right, y'all. So I did a survey, like I said, and my question was asking students how many hours they spent studying per week. Now, the first thing I'm going to do is I'm going to sort my data from high to low. So I'm going to highlight this column. So it looks like I had about 35. Whoops. So 35 of them. I'm going to go over here and hit sort and filter, and then sort from smallest to largest. So over here, for my low value, I can tell that that was 3. My high value was 20. So that's 2 things you're going to need, okay? All righty. First, you're going to have to figure out the frequency. So I made my bins, since mine were pretty much from 3 to 20, I made my bins go from 1 to 5, 6 to 10, 11 to 15, 16 to 20. So I'm going to look at how many did I have from 1 to 5. So I had 1, 2, 3, 4, 5, 6, 7, 8, 9. So I had 9 of them that were between 1 and 5. Now, y'all, what I did here to get the cumulative frequency for my formula for this, I said it equaled F2 because it's going to equal the frequency from the first bin. Now, what I did as I went through, this next one will equal this frequency plus the frequency I had before. And I just kept adding and going as I went. All right, so between 6 and 10, I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 of my points were between 6 and 10. So this formula right here, I set it up to add the new frequency plus the old cumulative frequency. So it took that 9, added the 16, and made that a 25. All right, next I need numbers between 11 and 15. So that'll be 12. That's 1, 2, 3, 4, 5, 6. 6 between 11 and 15. And y'all watch my cumulative frequency will go up. So on this formula, I took my G3, which was the old accumulation, and added the 6 to get to 31. All right, y'all, now I need 16 to 20. So I have 1, 2, 3, 4 values. All right, now watch my accumulated frequency will go up. It should equal the number of data points, which was my 35. So to get that, if you notice in the bar, I took G4 and added that G5 to get that. All righty, so other things you'll need is your mean. Now I'm going to work on charts next week. So this week I'm just showing y'all sort of how to get your frequencies and your cumulative frequencies. The mean, remember, that's going to equal. So put equals for the mean. Go up to formulas, more functions, statistical, and average. So it's going to be the average of the whole column. So that'll be A2 to A36. Okay. So my mean is 9.08. Median, that's going to equal, go to more functions, statistical, go down to median, enter, and then highlight that column. And okay. So the middle number was 8 on this, which we can sort of tell that's true. All right, the mode, that's going to tell me which one was the most. So I'm going to go to more functions, statistical, go down to mode. And I got a single column, so I'm going to do the mode of the single column from 3. Whoops. So I need to go to 36. So let me back that up and go to 36. All right, y'all hit enter. And my mode is 8. So if you notice, 8 happened 1, 2, 3, 4, 5 times. And that was the most of any of my data points. All right, so the lower quartile, that's going to equal the median. So more functions, statistical, median. Now, y'all, I got 35 values, so I'm looking for the lower 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So the lower 17 will give me my lower quartile. So hit OK. My upper quartile equals, go get that median again. And it's going to be the bottom 17. So let's see, that should start at, let's see, I got 35 points. So it should start here and go down to my 36. All right, y'all, hit enter. Standard deviation is going to be equals. Go up to your more functions. Statistical. Go down and get the standard deviation. And highlight the whole column. and okay. So my mean was 9. My standard deviation was 4. So that means 68% did between, what's that, 5 and 13. And then you can sort of bail it out from that, okay? All righty, y'all. So, um, if you wanted to learn to do the charts now, you would hit the insert. And I'm just going to do a chart based off of what I got right here. So go to insert. You'll see a place that says chart, and I'm going to click on the pie chart. And I'm just going to do a 2D pie. And y'all, right here's what it would give you. So we'll make it give percentages and all that fun stuff later. I'll show you how to label the chart and sort of put these percentages on it. See, like that, and 17%. I had the most data from 6 to 10. That was 46%. And I'll show you how to highlight that where it actually shows you those percents and everything, okay? So right now, I just wanted to get y'all good at finding how to put your frequencies down, how to make the bends, and then, like I said, how to find the mean, median, mode, and all that fun stuff. And y'all will be working on Excel each class to get y'all better at making your charts and everything else, okay? So, any questions? Oh, I like it too, Jada. And I'll get y'all better and better as we go. And the statistics stuff, we won't have to do an actual test over it. You just have these quizzes, okay? Our next quiz will be over stuff in the future over 8 and 9. Okay? So you just got to learn the statistics enough for the project. Okay? All right, y'all, let me make sure I got everybody here first. Let me make sure I got y'all. Bradford. Okay, so got you and I, Keisha, Erica, got you, Ashley, got you, Taylor, Josh, I got y'all, Aaliyah, I got you, Jasmine, Brianna, Jada. Y'all, looks like I got everybody. So I'm gonna stop our recording